Hi, I'm Maths 2018, paper 1, question 1. PQR is a triangle with vertices P minus 2, 4, R, Q, 4, 0, and R, 3, 6. Find the equation of a median through R. A median cuts the opposite line in half. It even shows you that, so let's call that M. To work out M, we can do minus 2 plus 4 divided by 2, and 4 plus 0 divided by 2. That gives a 4 take away 2 is 2, divided by 2 is 1, and 4 divided by 2 is 2. So we've got our midpoint, so we can now do the gradient between M and R, because it's not perpendicular, and then use y minus b equals mx minus a. So the gradient between M and R, we can do 6 take away 2, y2 minus y1, over 3 take away 1, x2 minus x1. That gives us 4 on the top and 2 on the bottom, which is 2. And now just use y minus b as mx minus a. So I've got y minus 2 is 2x minus 1. Y minus 2 is 2x minus 2. So y equals 2x minus 2 plus 2 is 0. This function is SQA Higher Maths 2018, paper 1, question 2. G is defined in a set of real numbers by a fifth of x minus 4. Find the inverse function of G. So I can just write y equals a fifth of x minus 4 and make x the subject. So I've got y plus 4 equals 1/5 of x, times on both sides through by 5. I get 5 bracket y plus 4 equals x. And therefore our inverse function of g is equal to 5 bracket x plus 4, or if you prefer, you could expand the bracket to get 5x plus 20. And we're done there. Okay, differentiating a trig function. SQA Higher Maths 2018, paper 1, question 3. h of x is 3 cos 2x, find h dash pi over 6. So if h of x is 3 cos 2x, then h, straight away you can just do h dash x is equal to minus sine 2x, well, minus 3 sine 2x, but then we need to times by 2 because we need to differentiate the 2x part as well. So that's minus 6 sine 2x. This is a paper 1 question, so it's an exact value question. So h dash pi over 6 is equal to minus 6 times sine 2 pi over 6, subbing it in. That equals minus 6 times the sine of pi over 3. Or if you prefer to work in exact values in degrees, that would be 60. So that equals minus 6, the sine of 60, root 3 over 2. 6 divided by 2 is 3, so it's minus 3 root 3. And we're done there. SQA Higher Maths 2018, paper 1, question 4. The point K lies in the circle with this equation. Find the equation of the tangent to the circle at K. Tangent meets a radius at right angles. So we need to find the centre of our circle. So we've got it in expanded form. So from the start of exam paper, we are told that x squared plus y squared plus 2gx plus 2fx plus c equals 0 is the equation of a circle, where the centre is equal to minus g minus f, and the radius is equal to the square root of g squared plus f squared minus c. So looking up at our equation, the number in front of f, 2g, is minus 12. And the number in front of y, 2f, is minus 6. So that gives me g is minus 12 divided by 2, minus 6. And it gives me f is minus 6 divided by 2, minus 3. So our centre is just simply 6, 3. Once we've got our centre, we can find the gradient between our centre. Let's just call our centre C. So the gradient between C and K is minus 5 take away 3 on the top and 8 take away 6 on the bottom. Minus 5 take away 3 is minus 8 over 2, which is minus 4. So the gradient of our perpendicular equals a quarter, since m1 times m2 equals minus 1. So our point is 8 minus 5 for K. So we can use y minus b, y plus 5 equals m x minus a, which is 8. Times it through by 4, we get 4 times y plus 5 equals x minus 8. So 4y plus 20 is x minus 8, or to leave it in a nice way, 4y minus x equals minus 28 would be a fine answer. If you prefer y equals, you can divide through by 4 to get y equals a quarter of x, and then minus 28 divided by 4 is minus 7 if you prefer. SQA Higher Maths 2018 Paper 1 Question 5, Vectors and Collinearity. A, B and C are collinear, state the ratio B to size A to C. So if B divides A to C, we can find A to B and B to C and then compare them. So let's do A to B first. Remember that's B minus A. So that is 5T5 minus 3, 4, minus 7. So now taking away them, 5 minus 3 is 8. T minus 4 and 5 minus 7 is 12. So we get our A to B. Now let's do the same for B to C. So that's C minus B. So that equals 798 minus 5T5. 7 minus 5 is 2. 9 minus T. Don't worry about them now, that'll be for part B. And 8 minus 5 is 3. And now we still need to compare the elements. The first element, 8 to 2, well that's 4. Divided by 4, 12 to 3 is 4. So the ratio that B divides A to C, B divides A to C, and the ratio 4 to 1. Part B, state the value of T. Well, we know that 4 times BC equals AB. So for part B, 4 times BC equals AB. So that means that we can say that 4 lots of 9 minus T is equal to T minus 4. 4 nines is 36, minus 4T is T minus 4. 36 plus 4, that gives you 40 on this side, equals 4T plus T is 5T. So T must equal 8. And we're done there. Okay, evaluating numerical expressions, SQA Higher Maths 2018, Paper 1, Question 6. Find the value of log 5250 minus a third of log 58. So we're going to combine these. So we'll keep the log 5250 hanging out for a minute. But we can say minus log 5, 8 to the power of a third. Because you can take coefficients up as a power. We'll work out that 8 to the power of a third then. So that's log 5250 minus, remember to the power of a third is the cube root. So it's log 52. And now we can combine a minus, because a minus means you can do this number divided by this number. So as 1 log, we get log 5, 250 over 2. That's log 5, 125. So 5 squared is 25, so 5 cubed is 125, so the answer is 3. Because 5 cubed is 125. And we're done there. SQA Higher Maths 2018, Paper 1, Question 7 for the equation of a tangent. You've got this curve shown in the diagram. Write down the coordinates of P, the point where the curve crosses the y-axis. So for part A, cuts the y-axis when x equals 0. So subbing 0 in, that's really easy. 0 minus 0 plus 0 plus 5. When x is 0, y is 5, so it's 0, 5. Part B, determine the equation of a tangent to the curve at P. The equation of a tangent, I can find the gradient by differentiation. So dy by dx is equal to 3x squared minus 6x plus 2. And at the point P already we know is x equal to 0, y equals 5. So when x equals 0, dy by dx equals 3 times 0 squared minus 6 times 0 plus 2. 0 plus 2 equals 2. So our gradient equals 2, and our point P, remember, is equal to 0, 5. So y equals mx plus c is the easiest one to use here. Y equals 2x plus 5. Or you could use y minus b equals mx minus a and still get 2x plus 5. Question C, find the coordinates of Q, the point where the tangent meets the curve again. So you're just going to solve simultaneous equations here. X cubed minus 3x squared plus 2x plus 5 was our curve. It's equaling 2x plus 5 at points of intersection. So we can solve that quite easily. If these cancel each other out, if we take it over, minus 2x minus 5, they disappear. So that just leaves me with x cubed minus 3x squared equals 0. Common factor of x squared, so you get x minus 3. So that means that x squared equals 0, so x equals 0, or x minus 3 is 0, so x equals 3. Well, we already know 0 is one of our points, so the second point of intersection is that x equal to 3. So when x equals 3, y equals 2x plus 5. So that is 2 times 3 is 6 plus 5, which is 11. The second point is 3, 11, and we're done there. Hi, Maths 2018, Paper 1, Question 8. The line has the equation y minus root 3x plus 5 equals 0. Determine the angle the line makes with the positive direction of the x-axis. Well, gradient equals tan theta if it's talking about angle and gradients. So let's get the gradient first. So y equals root 3x, take away 5, putting it in mx plus c form. Our gradient equals root 3, and gradient equals tan theta, which is equal to root 3. So theta is the inverse tan of root 3. The inverse tan of root 3 is 60 degrees, or pi over 3, and we're done there. It's an exact value. XB Maths 2018, Paper 1, Question 9 on vector pathways. It shows us a triangular prism, and it tells us some of the vectors. It says A to B is t, A to C is u, and A to D is v. Express B to C in terms of u and t. So I want to get from B to C, so I can go down this route minus t, and then along here plus u. Job done. B to C equals minus t plus u. And we're done there. Let's do part B. M is the midpoint of B to C. Express M to D in terms of t, u, and v. So we're wanting to go from M, which is here, all the way over to D, and we need to figure a pathway we can take. So we could go down here, along there, and up here. So I suppose we need to work out what M to C is. So let's do that. M to C is equal to a half of B to C, which is equal to a half of minus t plus u. So now we know that, then M to D is simply looking at our root, a half of minus t plus u. And then once we've done that, we go minus u plus v. Minus u plus v. Simplifying that, that's all minus a half t plus a half u minus u plus v. That's minus a half t, a half u minus u is minus a half u, and then we've got plus v. Done there. Just putting little lines underneath. Because usually that's how you write vectors or bold. Paper 1, Question 10. Given that dy by dx equals this, and y is 14 and x is 2, find y in terms of x. So dy by dx equals that. So if I integrate dy by dx, I get y back. So I can immediately say that y equals the integral of the left-hand side. 6x squared minus 3x plus 4 dx. And that's nice and easy. Want to do add 1 to the power, divide by the new power, minus 3x squared over 2 plus 4x plus c. Also remember your c. Tidying that up, y equals 2x cubed minus 3 over 2x squared plus 4x plus c. But we're told that when y is 14, x is 2. So when y is 14, x equals 2. So we can sub it in to get 14 equals 2 times 2 cubed minus 3 over 2 times 2 squared plus 4 times 2 plus c. Now, this is a non-calculator paper, so you just have to do this all manually. So 14 equals 2 2s are 4 times 2 is 8 times 2 is 16. 2 2s are 4 divided by 2 is 2 again. 2 3s is 6, so that's 6. 4 2s is 8, and then we get a c. 14 equals 16 minus 6 is 10, 10 add 8 is 18 plus c, and therefore c must equal minus 4. And we're done for c, so we just then say that y equals whatever we got before, 2x cubed minus 3 over 2x squared plus 4x, and then our c minus 4, and we're done there. Solving logarithmic equations, SQA Higher Maths 18, paper 1, question 11. Diagram shows log 3x. On the diagram in the answer book, sketch the curve of equation 1 minus log 3x, and then find the point of intersection between the curves, which will be solved with logarithmic equations. So 1 minus log 3x, the minus part here tells me to reflect in the x-axis, and then the 1 part, which I'll do in another colour here, tells me to then move up by 1. So first of all, reflecting on the x-axis, this point will stay where it is, but this point will jump down here, and that would be at the moment as in point 3 minus 1. But now I have to move up by 1, so this point is going to jump up by 1, so that becomes 1, 1. And you can see this point goes up to 3, 0. So I can just write the number 3 here. Getting rid of my intermediate working, which you could use a rubber if you were doing this by hand. And since it's reflected, it's going to go down and through here. So we can just draw that in, down here, through the way, and there we go. It's a reflection in the x-axis. Okay, part B, determine the exact value of the point of intersection. Simultaneous equations. So for part B, we've got y equals log 3x, but we've also got y equals 1 minus log 3x. So we can say that they are equal to each other and find x. So log 3x equals 1 minus log 3x. So taking the log 3x to the other side, you'll have log 3x plus log 3x. So 2 of them, 2 log 3x equals 1. I can take the 2 up as a power, so I get log 3x squared equals 1. Now I've got it in the form log of something equals a number, so 3 to the power of 1 equals x squared. 3 to the power of 1 equals x squared, and therefore I can find x. X equals 3 to the power of a half, or x equals the square root of 3. And we're done there. Notice it only be the positive part of this instead of the negative part, because if x was negative, then you would have log of a negative number, which doesn't exist, so it's just a positive. I can take a note of that. Just positive value, as x has to be greater than 0. SBA Higher Maths 18, paper 1, question 12 on vectors, addition and the modulus. Vectors A and B are such that A is this and B is that. Express 2A plus B in component form. So component form is when you've got the brackets. So we've got 2A plus B, well that equals 2 times A, 2 4s are 8, 2 2s are 4, and 2 2s are 4 as well, plus the B, which is minus 2, 1J, and PK. So then we can just add each element. 8 minus 2 is 6, minus 4 plus 1 is minus 3, and we've got 4 plus P on the end. And we're done there. Part B. B says, hence find the values of P such that the modulus of 2A plus B is equal to 7. Okay. Modulus is the size of, right? So we've got the size of 2A plus B. Well, that equals, it's just Pythagoras, square each numbers and square root. So that's the square root of 6 squared plus minus 3 squared plus 4 plus P squared, and that equals 7. Now, that's a bit unwieldy to do, so just square both sides to get rid of the square root. So that gives us 6 squared plus minus 3 squared plus 4 plus p squared equals 49. Expand the brackets and simplify. 36 plus 9. 4 fours are 16. 4 times p is p, times 2 is 8p. P times p is p squared. That equals 49. Moving everything to the same side and making it look like a quadratic then, because it's got a p squared, we get p squared. And then we've got 36 plus 9 is 45, plus 16 is 55, 61. So plus 61 on the end. And then we've got plus 8p in the middle. And that equals 49. So moving the 49 over to make it a quadratic we can solve. 61 minus 49 is 12. That equals 0. So hopefully that's factorizable. From National 5 Maths, 2 numbers at times to make 12 but add to make 8. That must be 6 and 2, plus and plus. And therefore, p equals minus 2 or p equals minus 6. And we're done there. Hi Maths, 2018, paper 1, question 13, double angle formula and addition formula. The right angle triangle in the diagram is such that sine x is 2 over root 11. Find the exact value of sine 2x. Well, sine 2x is 2 sine x cos x. So I can write that 2 sine x cos x. So I need to know my cos x, so let's go back to the triangle. Pythagoras to get the missing side, so I've got root 11 squared, which is 11, minus 2 squared, which is 4. 11 minus 4, 10, 9, 8, 7. So the missing side is the square root of 7. So that means I've got cos x is equal to root 7 over root 11. So that's 2 times 2 over root 11 times root 7 over root 11. 2 times 2 is 4, so I get 4 root 7 on the top. Root 11 times root 11 is just 11, so 4 root 7 over 11. So for part 2, cos 2x is 2 cos squared x minus 1 using the start of the formula sheet. So that's 2 times, well, cos x, remember, was root 7 over root 11. I'm going to square that and then take away 1. That's 2 times, root 7 squared is 7, root 11 squared is 11, minus 1. 2 sevens is 14 over 11, take away 1. 14 over 11, take away 1, so take away 11 basically is 3 11ths. So we get 3 over 11 as our answer for part 2. Part B, by expressing sine 3x as sine 2x plus x, find the exact value. So sine 2x plus x, this is the addition formula now. So start of the exam paper, sine 2x cos x plus cos 2x sine x. Now we've already worked out sine 2x and cos 2x at the top, so just using our answers, sine 2x is 4 root 7 over 11. Cos x was root 7 over root 11 plus cos 2x was 3 11ths and sine x we already know is 2 over root 11. So putting that together, we get 4 on the top. Root 7 times root 7 is just 7 over 11 times root 11 plus 3 times 2 is 6 over 11 root 11. 4 sevens is 28 over 11 root 11 plus 6 over 11 root 11. That's the common denominator, so I can just add them straight away. 28 and 6 is 34 over 11 root 11. And we could just leave our answer there. Getting with chain rule. SQA High Maths 18, paper 1, question 14. Find the integral between 9 and minus 4 of this function. Going to have to get it ready to differentiate first. So we've got between minus 4 and 9, 1 over. So it's the cube root. So that's to the power of a third. But it's squared, so it's to the power of 2/3. So it's 2x plus 9 to the power of 2/3 dx, which equals the integral between minus 4 and 9, taking it up to the top, 2x plus 9 to the minus 2/3 dx. And now we can integrate it. So we add 1 to the power and divide by the new power. So being very careful, we've got 2x plus 9. Add 1 is a third. Divide by our new power. So divide by a third, but also divide by this differentiated, which is 2. So I can say times 2 on the top bottom as well. And that is between -4 and 9, which I'll substitute in when I'm ready. Now this is a non-calculator question, so I'm going to have to put it back into root form as well. So that gives me 2x plus 9 cube root. So I can just write the cube root of 2x plus 9. 2 times a third is 2/3. And that's between -4 and 9. Almost done. Dividing by a fraction means we can times it by the reciprocal, flip it upside down in other words. So we get 3 times the cube root of 2x plus 9 over 2 between -4 and 9. And now I'm ready to substitute my numbers in. So substitute 9 in, take away, substitute -4 in. So subbing in my numbers, get 3 times the cube root of 2 times 9 plus 9 all over 2. I'll just put that in big brackets. Minus 3 times the cube root of 2 times -4 plus 9. I'll just make that clear that that's separate all over 2. And now we can work some of that out. So that's 3 times the cube root of 2 9s is 18, 18 and 9 is 27 over 2, minus 3 times the cube root of 2 times -4 is -8, add 9 is 1 all over 2, and that's handy because that now simplifies quite easily. The cube root of 27, 3 times 3 is 9 times 3 is 27. So this just gives me 3 times 3 over 2 minus cube root of 1 is 1. 3 times 1 over 2. That equals 9 over 2 minus 3 over 2, which equals 6 over 2, which equals 3. And we're done there. Unusual question, SQ Hand Maths for 18, paper 1, question 15. A cubic function is defined a set of real numbers. X plus 4 is a factor, x equals 2 is a root, f dash minus 2 equals 0, and f dash x is greater than 0 when the graph crosses the y-axis. X plus 4 is a factor means that x equals -4 is a root. That's where it crosses the x-axis. X equals 2 is a repeated root, which means that it's also a turning point on the x-axis. That's what happens when you've got a repeated root. So we can start drawing a graph. We can look at the other options in a minute. But if we draw a y and x-axis, just a quick sketch, we've got -4 as one of our roots, and we've got 2 is, I'll just put it here actually, as another root. And when looking at our derivatives, f dash of -2 equals 0. So we now know that at -2 at some point, we've got a turning point as well, not on the x-axis, but then we also know that f dash x is greater than 0 when it crosses the y-axis. So we know that it's going up at this point, but this is a turning point, so it must drop back down. So we now know that it must go like this. And we know that this is a turning point, so it must turn here and go up here because that's a root. So we've got our root, a repeated root, and we're done there.